Hello, Year 9. How are you? It's Mr. Parr here. This lesson is going to be the first lesson in your next unit, which is sorting algorithms. Now, we've done some work on algorithms in Year 7 and Year 8. In Year 7, we looked at flowcharts, so we can use flowcharts to write algorithms. And in Year 8, we looked at using pseudocode to write algorithms. At least I think we moved on to it. I can't remember, depending on when lockdown started. Anyway, this unit is all about what's called sorting algorithms. Okay, I think in Year 8 we did searching algorithms. Today it's all about sorting algorithms. Okay, so this lesson I'm going to be working through some slides on PowerPoint. I'm also going to be asking you to refer to the workbook. Now, this workbook has been sent to you along with this link via Go for Schools. Okay, obviously, if we were in school, this would be printed for you and you'd fill out as we go through. Obviously, we can't do that. So whichever way you can, use this workbook. So if you've got it at home and you've got a printer and you're allowed to, print it out, brilliant, fill it in, bring it in when we're allowed back in school. Or alternatively, you can't print it out, just fill it in online and just save it if you want. Or if you wanted to, just on a separate piece of paper, just write down your answers. And bring them in whenever you can. This workbook's for you to build up and help you revise. Now, if for whatever reason you can't open it, just email me or Mr. Clements and we can send you a different version of it. Okay, so this is the workbook. Let's just familiarise ourselves with it. Space for your name, group, and your target grade. Your target grade, if you don't know it, your teacher can tell you that or tell you when you come back to school. There's space to log our scores for our previous units. We've got a contents page, so if for whatever reason you're stuck or you can't remember which page you're working on or you've missed a lesson, we ask you to go back and work on it. Just use the contents page to help you. And then you can see here the first thing on there is, is it on there? Oh, maybe not. Okay, we've got loads of starter activities. Okay, so these are activities which you'll be expected to do at the start of each lesson when you're back in school. So, for example, come to a lesson, I'll just say, right, get cracking on with starter 1 or starter 2 or starter 3. So that way we're not waiting for me to log on and get everything sorted. So the first few pages are loads of different starter activities, okay? And the actual work starts on page 9. So first thing I want you to do is have a look at pages 9, 10 and 11. All it is, it's a bit of a recap of what we did in year 7 and 8. So on page 10, there's an activity there. So read through the flow chart and you have to say what's going to be displayed if these numbers are entered and then explain what that algorithm does. That's on page, what's that, page 10. And then page 11, we've got a pseudocode algorithm. Okay, so you have to read through that and then imagine you put in 8 adults and 0 children, what would be displayed. Okay, so what I want you to do is to pause the video, have a go at those questions, and then I'm going to go through the answers. Okay. Okie dokie, right then, let's start my PowerPoint. Okay, and let's go through these answers. So what we've got here, we have an algorithm and it asks us to input 2 numbers and then it's going to display one thing or the other. So let's work it through. Is my pen working? Hello? Yes, it's over here. Oh, I want to do that. No, it's not. Bear with me. How do I get me? Oh, pointer options. I want a pen. There we go. That's better. Right. So we've got to imagine that we put in num1 is 5 and num2 is 6. Okay. So I'm just going to unplug my tablet thing because it's playing up. Let's try again. That's better. That's better. So if num1 is 5 and num2 is 6, so we've entered those in. So num1 is 5 and that's 6. Now it's saying here, is num1 and that symbol greater than? So this is what's called a conditional statement. Okay, is num1 greater than num2? So is 5 greater than 6? No, it's not. So we go this way. So there's output num2. So num2 is 6. That's output, and then it ends. Nice and simple. Next one. So this time, num1 is 7, and num2 is 7. So is num1 greater than num2? Or no, because they're the same. So once again, we output num2, 7. And the last situation, let's say num1 is 1, num2 is 2. Is num1 greater than num2? No, it's not. So we output num2. So in all 3 instances, Okay, it's always no. So explain what the algorithm does. So it takes two numbers as inputs. Okay, that's the first two bits there. It then displays the larger of the two numbers. It's a simple algorithm, and it just compares two numbers and displays the largest one. Some of you might have noticed that there is something wrong with it, and that is here. What if the two numbers are the same? Okay, well, it hasn't actually displayed the largest one. I suppose it has. So what you would really want to do is add an extra bit to the algorithm to display if they're equal as well, or if they're the same. Okay, so the next one was a pseudocode algorithm. We've got Sparky Autos gives discounts based on the number of visitors in a group. Oh, Sparky Autos, interesting. The pseudocode for an algorithm that determines group discounts is shown. So we've got, I'm not going to talk it through, but this is a pseudocode algorithm. All right. Complete the table below, show the output of the pseudocode algorithm based on the given input. So first of all, we're going to imagine we've got the number of adults is 8 and number of children is 0. So if the number of adults is greater than 1, so is 8 greater than 1? Yes, it is. And number of children greater than 0. Is 0 greater than 0? No. So that means because these two conditions aren't met, then we move on to else. Okay, it's only when we meet both these conditions we do this below. So now else, if number of adults is greater than or equal to 10, well, 8 isn't greater than or equal to 10. So then we move on to else. If number of adults is greater than or equal to 5, well, it is, then, oh, send small group discount to display. So that's going to be small group discount. There we go. That's that first one done. Let's go back. 2 adults, 2 children. If the number of adults is greater than 1, well, 2 is greater than 1, so that's correct. And number of children is greater than 0. Well, yeah, we've got 2 children. Okay, so it meets both of these conditions. So we do what's below. Send family discount to display. So that is family discount. Okay, last one. Number of adults is 12, no children. So 12 is greater than 1, but we haven't got any children, so move on to else. So number of adults greater or equal to 10. Well, it is because it's 12. So then it's going to say large group discount. Large group discount. Okay, so there you go. Those first 2 activities are just little recaps of algorithms and reading algorithms. So flowchart and pseudocode algorithms. Right. So this unit, we're going to focus on what's called sorting algorithms. In year 8, we did searching algorithms. So how do computers actually search for data? We do it all the time. We're searching on Amazon or on Google, whatever. We put something in, and the network, the computer, actually searches something. And we looked at what's called linear and binary searches. And if you can remember, a binary search works, and it's really efficient, really quick, but only works if the data is in a specific order. So this unit is looking at, well, how does the computer put stuff into order to allow it to be searched? And so we're going to look at 3 different sorting algorithms. This lesson is going to focus on what's called the bubble sort. Okay, so all of us, hopefully all of you, should be able to perform a basic bubble sort on a set of data. Okay. So most of you, hopefully, I don't know if you get a chance because we're working from home, is performing bubble sorts on different types of data. Okay, so text as well as numbers, and correctly demonstrate passes through a bubble sort. Okay, the challenge will be to go away and find out, well, what's the advantage of using a bubble sort, and how do you calculate the number of passes through? And that will make sense as we go through. Okay, so as I said, why do we need to do this? Why do we have to sort data? So it makes it easier to search, but also it's easier to display. So there's some typical examples. I mean, whenever I go onto Amazon and buying a present, because I'm quite tight, I always do it from cheapest to most expensive. Currently, we're looking at buying a new sofa. Go online, what's the cheapest to the most expensive. We can all put stuff in a particular order. There's an example in your contacts. It's done alphabetically. So sorting is really important when it comes to displaying data and organizing your data. And you've got to think, well, how do computers do it? We sort things automatically. And normally what I do in a classroom, I get people to organize themselves into height order. Now I ask people, how did they go about doing it? Okay. And our brains are quite complex. We are intelligent species, and we do things without even thinking about how we've learned how to do it. So as I always say, computers are stupid. They have to be told exactly what to do. So sorting algorithms have been developed over many years, and they are literally sets of instructions to tell a computer how to sort some data. Okay, so we're going to start first of all is looking at what's called a bubble sort. Now, can't do this activity because we're not in a classroom. So I'm going to talk through how I'm going to describe a bubble sort. I'll demonstrate it as well a couple of ways. So the bubble sort, let's read it through. Each item in a list. Now, what I mean by a list is basically like a set of data. Lists, traditionally, we read them, it's like a shopping list, top to bottom. In this case, the data is going left to right. So here at the bottom, 9, 5, 4, 15, that's a list of data. So each item is a list compared to the one next to it. And if it's greater, they swap places. At the end of one pass through the list, the largest item is at the end of the list. This is repeated until the items are sorted. Right then. So the easiest thing to do is for me to do an example. Okay, so I'm just doing this off the top of my head. And let's just do some numbers. Let's do some relatively low numbers. Let's have 5, 7, 3, 9, 6, and 8. Okay, so that's our list of data. There are 6 different numbers. Okay, and what we want to do is to sort them into ascending order from lowest to highest. Okay, so this is how a bubble sort works. We start off with the first item in the list. I'm going to underline it, and we compare it to the second item in the list. Okay, and we're just comparing them. We say which one's bigger. Is 5 or 7 bigger? Okay, well, 7's bigger, so we keep it exactly the same. Okay, so I'm just going to write below exactly the same. 5, 7, 3, 9, 6, 8. So the first thing is compare the first 2 items in our list. Okay, they are already in ascending order. Okay, then we look at the second and the third items. Now just looking at 7, 3, we're comparing those. Are they in the right order from lowest to highest? No, they're not. So they swap places. Okay, so underneath, I'll then write it again. Oops. This time after they've swapped places. 5, 3, 7, 9, 6, 8. Okay. Then we look at positions 3 and 4. 7 and 9, are they in the right order? Yes, they are. So 5, 3, 7, 9, 6, 8. Then we look at positions 4 and 5. Are they in the right order? No, they're not. So we just swap those 2 around. 5, 3, 7, 6, 9, 8. And then we look at the last 2. Are they in the right order? No, so we swap them around. 5, 3, 7, 6, 8, 9. So as you see, each time you just compare 2 numbers at a time. The first 2, so items 1 and 2, then 2 and 3, then 3 and 4, then 4 and 5, then 5 and 6. Okay, and you just swap them around. Okay, so what we've just done there is what's called the first pass. In other words, we've passed through all of the numbers and we've swapped any ones around which were in the wrong order. So there we go. Are they in the right order? No, you can see, you know, that a lot of this isn't necessarily in the right order. So what we have to do another pass through. So what I'm going to do is copy these up here. So 5, 3, 7, 6, 8, 9. Okay. So I'm just going to move them up there because this is the order they're in after the first pass. And we start again on the second pass. So we compare 5 and 3. Okay, well, they need to swap because 5 is bigger than 3. So now we've got 3, 5, 7, 6, 8, 9. Okay, then we look at items 2 and 3, 5 and 7. They're okay, they're in the right order. Okay. Now we look at 7 and 6. Well, they need to swap because they're in the wrong order. So 3, 5, 6, 7, 8, 9. Okay, a lot of you can see now that it is sorted, but we need to carry on through. So then we look at 7 and 8. They're okay. 3, 5, 6, 7, 8, 9. Then we look at the last two. They're okay. 3, 5, 6, 7, 8, 9. Okay, so that is the second pass. You can see after 2 passes, the items are now sorted. Okay, so 3, 5, 6, 7, 8, 9. Okay, now if you were actually writing this, you would have and as an algorithm, what you'd have to do is have to do a third pass through. Okay, and what the third pass through would do is it would go through and check to see there's no swaps. So what you do, you'd see, well, have any been swapped around? So during the second pass, okay, we know there's been a couple of changes, all right, but we can see that. A computer wouldn't know, it wouldn't know when to stop. So what you do is you do a third pass through to check, and if there's no swaps, then that means it is sorted. So the data is sorted after 2 passes, okay, and then you do a third pass to check. All right, I'm going to do another example. All right, let's do and let's get one more animal, a lion. All right, so this time let's just get this into alphabetical order, and let's use a bubble sort. All right, so if you remember, we look at the first 2 items first in position 1 and position 2, and then in the right order alphabetically. Well, C comes before P, so yeah, so cat, pig, dog, ant, lion. Okay, then we look at positions 2, pig and dog. All right, we need to swap those around, don't we? So cat, dog, pig, ant, lion. Remember, each time we're just looking at 2 at a time. So positions 3 and 4 now, pig and ants need to swap round. So cat, dog, ant, pig, lion. And then we'll look at the last 2, pig and lion, then swap round. So cat, dog, ant, lion, pig. So that is the first pass. So we pass through all of them, and it's still not in the right order. So let's just copy those to the top for the second pass. So cat, dog, ant, lion, pig. Looking cat and dog, they're in the right order. So cat, dog, ant, lion and pig. Then we look at dog and ant, need to swap. Cat, ant, dog, lion, pig. Then we're looking at dog and lion. They're in the right order. Cat, ant, dog, lion, pig. And we look at lion and pig. They're in the right order. Okay. That was the second pass. Oh no, it's just copied again. So cat, ant, dog, lion, pig. So after the second pass, they're still not ready, still not in order. Let's do a third pass. So cat, ant, dog, lion, pig. Cat and ant need to swap. Ant, cat, dog, lion, pig. Then we look at cat and dog. I'm not going to bother copying these down now. Then we look at dog and lion. They're in the right order, and lion and pig. So quite clearly we can see after 3 passes that the data is sorted. You do a 4th to check. Okay, so that, ladies and gents, is the bubble sort. Okay, I'm going to play you a YouTube video, and it's just a visual representation of how this kind of works. Okay, hopefully the sound will be all right and it's not too laggy. If it is, just jump ahead on the video by about, well, 2 minutes and 43 seconds. See, girl on right turned around because she's now sorted in the right order, so she's just turned around. Okay, so hopefully that kind of gives you a visual representation of how that works. Okay, if you're quite happy with how it works now, what you can do is you can have a go at the activity, which is on, well, page 12, kind of reminds you of how it works. I'm going to go through that again for anybody who needs it. So on page 13, here's an example question. Okay, one which is fully completed. It says 6 athletes compete in a long jump competition. Their best jumps are shown below. Okay, so you've got 5.32 meters, 5.5, 5.39, and so on and so on. It says show the stages of a bubble sort to list these jumps in order from shortest to longest. So for the first pass, we've just copied in the data in the order which is presented at the top. So here is comparing the first 2 items, 5.32 and 5.5. They're in the right order, so it's copied exactly the same below. Then we look at items 2 and 3, 5.5 and 5.39. They swap round. So if you look below, it's copied down, but they've swapped round. Okay, then we look at 3 and 4, which is 5.5 and 6.5. They're the same. So it's copied down below. Then 6.5 and 6.28 are compared, and they're swapped round. And then it's done again there. And then at the end of the first pass, this is the order. Okay, and you can see it's not necessarily in the right order. So these 5 numbers here are then copied to the start of the second pass, and then we start again. So the yellow indicates the 2 numbers which are compared, and then in the next row below, you're just writing them down, after they've swapped. So here, this one includes a 3rd pass to check to see. If there's no swaps, then that means it's sorted. Okay, so there's an example question. So you guys, you can't do that one group task because we're not in a group. So here we go, nice easy one. It says show the stages of each pass of a bubble sort when following the sorting data into ascending order. So you can see we've copied it down. You can see the first comparison is 4 and 12. So we compare those and they need to swap. So then we'd have 4, 12, oops, 12, 32, 40, 20. Okay. And then you'd compare those two and so on and so on. Okay. And this is an exam question. So Willow has created a Hangman program that uses a file to store the words the program can select from. Sample of data shown there. Crime, bait, fright, victory, nymph, loose. It says show the stage of a bubble sort when applied to the data. It says in your answer you can show the order of the words after each pass. Okay, so you haven't got to show every single comparison. Okay, so I'm doing this in my head. So I'll tell you what I'll do the first pass for you. So crime, bait, let's copy that. So I'll do the first pass for you. Let's discard that. So crime, bait, fright, victory, nymph, loose. Okay, I need to get my pen back up. There we go. So in the first pass, I'll compare crime and bait. Okay. Why is this not working? Oh, odd. Keep, discard. Sorry. Let's go back. Start it again. See if this is working. Nope. I just love it when technology works. Let's try again. Pen. No, we're not working for some reason. One more time. No, never mind. Right, let's try and do it. Let's try and explain it. So let's go back to it. So in the first pass, crime and bait would swap. So I have bait, crime, fright. Crime and fright would be the same. Okay. Fright and victory would stay the same. Victory and nymph would swap. Okay. And then nymph and loose would swap. So after the first pass, it would be crime, nymph, loose. Okay. So then you do it again, you do the second pass. Okay, and what order would it be after the second pass? Okay, so you haven't got to show every single swap, just what order would it be after each pass? Okay. Last question is explain why data needs to be sorted, giving 2 example where used in everyday life. Okay, so those are the activities I want you to have a go at. Feel free to go ahead and do it. What I'm going to do now, I'm just going to go back and just do one more demonstration for anybody that needs it. Okay. Right, let's go back to this then. So here's an example of this data. So this is exactly the same as what I've just done. So we've got, there's our data, 9, 5, 4, 15, 3, 8, 11, and 2. So each item is compared with the one on its right and swapped if larger. So 9 and 5 are compared, so they swap around. So on the next row, we've got 5, 9, 4, 15, 3, 8, 11, 2. 9 and 4 are compared, they swap around. So you've got 5, 4, 9, 15, 3, 8, 11, 2. Okay, it says at the end of the first pass, the largest item bubbles to the end of the list. So that's where it comes from, the bubble sort. So the way it works is the larger numbers bubbles up to the right. So you can see there after the first pass, the largest number has then gone up to the right. Okay, so that's the purple or mauve, the color. So after the first pass, we have 5, 4, 9, 3, 8, 11, 2, 15. That's the order. Then the second pass. Okay, we go through again. I'm not going to talk through every single comparison, but you can see there as we go through, the 11 has now bubbled up to the right hand side. Okay, then after the third pass, okay, we have, oh no, second and third is on the same page. Yes, the third pass is on the right hand side there. So 9 falls into place. The third pass, okay, then the fourth pass we have 8, and then the 5th pass 5, and so on and so on and so on. Okay, so 7 passes through the list of 8 numbers ensures that they are sorted. Okay, there we go. So that's it, ladies and gents. So what I like to do is have a go at those activities. If you get stuck, by all means, send me an email, or Mr. Clements an email, or just Google it. Okay, and hopefully that should make sense. Okay, hope you're all well, and speak to you soon.